Let me do this integral by 4 methods. The integral itself is not difficult, but the methods, the 4 methods, what I'm discussing here today, are interesting. See, the first method, well, that's the method that mostly often used. That is by parts, right? You must have seen this type of integrals when you learn the method of by parts. So I'll start with this method. I write this one as a sine 3x and the d e to the 2x, which means that this is u, this is dv, right? By doing so, I maintain the equal sign. I must multiply half because this one has a 2 dx. Now then, I can start by parts. uv, u, v minus v du. v is this, right? Du is a cosine 3x times 3 dx. Right? Good. Then this one is equal to 1/2 e to the 2x sine 3x minus, and I'm going to start with the by parts again. This will be 2 e to the 2x, right? By taking this one times half, right? Because this one is a 2 dx. Okay, then this one is equal to 1/2 e to the 2x sine 3x. This will be minus 3/4 uv minus v du. Minus become plus, right? So yeah, 3/4 integral. This will be 2x, and this derivative is a negative sine 3x times 3 dx. Yeah, good. So this one is equal to 1/2 e to the 2x sine 3x minus 3/4 e to the 2x cosine 3x. This will be negative 9/4 I, right? This is original I. This is my original integral. So I move over there. Yeah, then I get I is equal to 1/32x and 2 sine 3x minus 3 cosine 3x. Okay, that is the first method. It's nothing difficult, but everything is straightforward. Okay, now look, I want to say something here. Now, when you started by parts, right? I can choose this one as my dv. Also, I can choose this one as dv. But once you choose this as a dv, then next time you have to keep that way. You cannot change it. So change it. Cosine 3x dx is my dv. No, it doesn't work. You will go back. So once you choose this was dv, next time you keep that way, you keep cosine dx as a dv. When you choose this one is my dv, then you keep that way, for the next by parts. Okay, that's what I want to say. Okay, now the second method, method two. Method two, it's e to the 2x sine 3x dx. Okay. Now, the second method, I call this integral is I create integral j, that is e to the 2x cosine 3x dx. Okay, then my I plus j would be equal to e to the 2x sine 3x plus cosine 3x dx. Then I consider this is my dv. So this will be equal to integral 2x d sine 3x minus cosine 3x. This integral is this integral is that, and then multiply by 3dx, right? So I don't have a 3dx, just to maintain equal sign, multiply 1/3. Okay. So this will be equal to 1/3 e to 2x times uv, right? U times v minus v du. V, this will be this derivative. This derivative is e to 2x times 2. So I have a 2 here, 2x times sine 3x minus cosine 3x and a dx. So this one is equal to 1/3 e to the 2x sine 3x minus 1/3 of a e to 2x cosine 3x minus this time this will be 2/3 I and plus 2/3 over j. Yeah, good. Then this side is I plus j, right? Then I multiply by 3 and move I, j over there. Well, I get 5i plus j is equal to e to 2x sine 3x minus e to 2x cosine 3x. Yeah, good. Okay, the constancy is there. All right, that is one equation I created. Now to find I need two equations, two simultaneous equations. Then I can find I, right? And then I'm using this. I minus j is equal to e to the 2x sine 3x minus cosine 3x dx. Yeah. Then I do the similar thing. The derivative of sine 3x plus cosine 3x. This one is a cosine. This one is a negative sign. So I have a negative times 1/3. Yeah. To maintain equal sign. Okay. This one, because the derivative is negative, and 1/3 is for the chain rule, 3x. Okay, then I can have uv minus 1/3 e to 2x times v minus become plus v du. This is v, right? This is sine 3x plus cosine 3x times du. Du is e to 2x times 2. No, times 2 in the front. Okay. Yeah. So this will be equal to this I minus j. Okay. I minus j equal to negative 1/3 e to 2x sine 3x minus 1/3 of e to 2x cosine 3x plus, this is I, right? 2/3 I. This is j. Yeah, then if I multiply by 3 again, so this 3i minus 3j is equal to negative e to the sine 3x minus e to the 2x cosine 3x. Yeah, this will be 2i minus 2j. Yeah. So if I move there, this will be I minus 5j. Yeah, is equal to 1/3. No, and that will be negative 1 sine 3x minus e to the 2x cosine 3x. So that is my second equation. And from these two equations, I can find I and j, right? So I is equal to 113 e to the 2x 2 sine 3x minus 3 cosine 3x plus c. All right, so I find I from these two equations. Yeah. Okay, this is the second method. Now the third method, this is e to 2i sine 3x dx. I call this one as I created j, which is e to 2x cosine 3x dx. Now, uh, if I differentiate this function with respect to x, so this would be equal to 2e to the 2x sine 3x plus 3e to 2x cosine 3x. Well, I'm using the product rule and the chain rule. That's easy. And also, I consider this derivative with respect to x. This is 3 here. And this will be 2e to the 2x cosine 3x minus 3e to 2x sine 3x. Right? That is the product rule and the chain rule. So I get these two equations. Now, this equation, if I integrate both sides with respect to x, so this side will be e to the 2x 3. I'm sorry. If I differentiate both sides with respect to x, this side will be e to the 2x sine 3x. This side will be 2i plus 3j, right? This is 2i, this is 3j if we integrate. And this would be e to the 2x cosine 3x. Integrate with respect to x, that will be 2j. This will be minus 3i. And by solving these two equations, then I get I, right? I is equal to 130 into 2x 2 sine 3x minus 3 cosine. So that is done by third method. I think this method is very good. Very good. And lastly, the fourth method. Let me use a new paper. Okay, the fourth method. I is equal to integral e to 2x sine 3x dx. The fourth method, I'm using complex number. So this one is equal to imaginary part of e to the x and e to the 3ix dx. Yeah, because this is a complex number, right? Cosine 3x plus I 3x. Then if I take the negative imaginary part, that is my given integral. So now I can combine these two. This becomes 2 plus 3i x dx. And this integral is easy. This becomes 1 over 2 plus 3i e to the 2 plus 3i, right, plus c. Now I have time. I multiply by the conjugate. So 2 minus 3i. This will be 4 plus 9. Now, this is equal to what? This is equal to e to the 2. Yes, I forget x, right? Yeah. Okay, that is a 2x multiplied by cosine 3x plus I sine 3x. Let's see, right? Yeah. Then I just pick up the terms of a imaginary number. So this this will be equal to what? This will be equal to imaginary number of 13 e to the 2x, right? That is 2 minus 3i times cosine 3x plus I sine 3x plus c. I just pick up the imaginary number, imaginary term, right? So 30 e to 2x. This one time, this one is a real. No, I don't need it. This one time, the other one, yes. Sine 3x. That's imaginary. This one time, this one, yes. Minus 3 cosine 3x. Yeah, that's it. See, that is a very good method. Okay. So this integral itself is not really difficult, but the methods, the 4 methods I'm discussing here are interesting. Thank you.